Thanks everybody for kind of coming in. It's quite a big room, so we're going to be having fun. The idea for this talk is to kind of tell you a bit how I burnt my fingers trying out lots of different things. I've read this article last year that software development's changed so much. It's no longer kind of anything to do with science. It's mostly development by poking, where people try and figure out how stuff works and then suffer until they make it work. And a lot of it is really like that, and I've played with something in particular over the last year quite a lot. That's kind of cloud functions. Different providers call them differently. Amazon calls it Lambda, Microsoft calls it Azure Functions, and Google has Google Functions and things like that. And it's not, the naming, I guess, is always a bit problematic. It took a lot of poking and peeking and things like that until we made it work, and I think we made it work incredibly well now. So that's kind of what I want to talk about and hopefully give you some ideas that you can try out, or if you're already trying those things, maybe learn from my mistakes. And one of the first things that I really think is interesting is that cloud functions kind of that came on the scene last year are probably, at least for me, the most revolutionary thing that happened since virtual machines in the cloud. I'm incredibly excited about the whole thing, and it took me about 4 months to really kind of realize what happened and why they're so revolutionary. And if you read docs online, it doesn't sound that great at all. It's kind of, okay, write a function, run it. It's kind of pretty much the same thing. But I think it changes the set of incentives under which developers work to something truly revolutionary. And that's kind of part of where we're going with this. Now, a lot of what I'll be talking about comes from my experience with a particular product that I'm building. It's a mind mapping online collaboration tool. And we started building that kind of about 4 years ago. I'm an early adopter of kind of VMs in the cloud because that sounded fantastic. And we started using VMs in the cloud maybe 2007 on kind of some other stuff. And before that, kind of, in year one before cloud, what people used to do is, if you wanted to host a service, you'd get kind of the browsers to connect to some machines that you maintain and some database that you maintain and things like that. I started working in software kind of around the time where if you sold somebody an accounting app, that gave them the right to harass you for 6 months whenever their email server goes down. And for a long time, kind of the most amount of money I made in an hour was resolving the internet not working for a client where it was the proxy server running out of temp space, full of smut and stuff like that. So I was a reasonably good Linux admin for a while. I wasn't any kind of rockstar Linux admin by far, but I knew how to do admin stuff. I knew how to reset Cisco routers. I knew how to set up databases. I knew how to do a ton of other things. And that's why kind of that happened to me from day one, pretty much, when we started making money from programming. So I never really understood the whole DevOps revolution coming later, because kind of that was always a part of the job for me. But that's not a particularly part of the job that I enjoy very much. And I've realized that I don't want to deal with those problems. I want to deal with some other problems. So when Amazon started offering VMs for free in kind of year one of Amazon dominance, I kind of realized that pretty much it doesn't matter how good I or my colleagues get with kind of adminning the databases and adminning storage and stuff like that, Amazon is going to be a lot better. And the first thing that we did then is kind of the whole immortal storage that we had to maintain. That took a lot of power and knowledge and things like that. And when S3 came along, that was like a revelation for us. So the first, I think, thing that lots of people did with the cloud is start using files in the cloud, kind of year one of Amazon dominance, files. Now, after a while, people realized, well, you know, now we can start putting VMs and stuff like that there as well. Why are people connecting to our servers? Why do we have to maintain network connections, routers, and stuff like that? And then we started kind of renting VMs from Amazon. But I don't know if anybody tried to rent VMs from Amazon in 2007. Yeah, one person. There was still patching operating systems, still dealing with a ton of crap I didn't want to deal with. And kind of over time, the next, I guess, big revelation for me was that these VMs, I shouldn't really think about them as normal computers, because normal computing servers, we'd put stuff on that served JavaScript, we'd put stuff on that served CSS, we'd put stuff on that served images, we'd put stuff on that served dynamic content. And we're just sweating these VMs without any reason, and we're maintaining more VMs than we need. What we should really do is start pulling out some assets and stuff like that, and this is where kind of all those CDNs started becoming really popular, because we realized the cloud is starting to change how we structure our apps. Now, at this point still, kind of the incentives were pretty much the same. And the incentives for this, at least for me, were keep the stuff you bought busy. Because we needed failover, we needed load balancing and stuff like that. We'd get 4 VMs, and everything goes in those 4 VMs. And a ton of code that's not necessarily related to each other goes into those 4 VMs because we paid for those 4 VMs, we have to keep them busy. It made no sense for every single conversion we have to do with the files to create a separate set of VMs. It's just stupidly expensive because they're not going to be doing anything in it all the time. Now, as we started doing this, Amazon was kind of a bit late to the next stage of the game. This is where kind of Google slightly started taking over, and then Azure started taking over. People realized that we don't really need to kind of maintain VMs, and people don't want to talk about VMs, they want to talk about apps. And they want to talk about, I want to run a Node.js app in the cloud, I don't care about Node.js security, I don't care about port filtering, I don't care about setting up SSLs, I want to run an app, or a PHP app, or whatever. And then kind of this is where I kind of got in again into kind of the cloud thing with MindMap, and for us, the app platform was Heroku. Heroku was magical when I saw that. You do a git push, it does stuff, you scale up, scale down, it does load balancing, it does routing, it does a ton of other things. It was completely magical for me. But the incentives are still the same. You pay Heroku for a VM, and our app converts mind maps into a ton of other formats. PDFs, images, Word, PowerPoint. Setting up a separate set of VMs with failover, with routing, for each of those formats would just kind of quadruple our costs. So the incentive is keep it together, which means the incentive is basically overcomplicate the stuff so more of it can fail at the same time. Plus, there was this big thing with Heroku a couple of years ago where somebody found that they were, depending who you listen to, either had a bug or defrauding their customers for kind of doing routing incredibly stupidly. And they were doing routing basically, if you have 4 VMs and 3 of them are busy and 1 of them is free, and a request comes in, it's very, very likely that it's going to hit one of those 3 busy VMs. And in particular, kind of with the app structure they were using then for Ruby, we were running on Ruby, it was 1 request at a time. Although you can use kind of multi-threaded VMs and stuff like the way they were routing is 1 request at a time. So you have 4 VMs, you can process 4 requests. Before that, when we had immortal stuff, well, with 1 machine I can process probably 2,000-3,000 requests if I've optimized it well. Now I can process 4 requests with 4 machines. It doesn't sound that good. And kind of this is where we started looking at, well, now we have all those kind of apps, and we're still using the cloud storage and things like that. The next big thing for us was to realize that maybe all those file uploads and file downloads and stuff like that don't really need to go through our VMs. Maybe we're doing it wrong. We're blocking those 4 or 5 or 20 VMs with big files coming through where Heroku is routing it stupidly. And we started looking for some other things, and we realized, well, we're using Amazon S3 anyway. And we're thinking about it as storage, but maybe we should be thinking about that more. We're giving people direct access to our assets on the CDN. Why not give people direct access to files and kind of work with S3 security? And this is where I realized, well, S3 is a lot more than a stupid storage. It gives you an API. It gives you an API that the browser can connect to directly, so it doesn't even need to go through your storage. It doesn't need to go through your VMs. It doesn't need to clog up that. And this is where kind of we slowly started doing something. It took me about 2 years to understand what we were actually doing. And we were thinning and thinning and thinning our app until our app actually just became a configuration set. Our app became something that configures the initial HTML file. And the initial HTML file gets kind of configured to access all these endpoints. And the browser is just kind of spinning all these endpoints. And we're paying Heroku for VMs to basically generate what's a reasonably static file. It changes maybe every week or so. Or if we're doing more frequent deployments, it changes 5 times a day. But still, it doesn't change with every request. And then we started kind of moving the index page to the CDN as well. And over time, I realized that we started thinning out the main app so much, it's no longer an app. It's no longer what people connect to. What people started connecting to is a bunch of static pages. And those static pages kind of serve the stuff. And people were then connecting to some APIs in the background, whether it's us or Amazon or something like that. And we kept VMs on Heroku mostly to run these APIs. Now, at this point, we're still using Heroku. It's still kind of the same set of incentives. I run it in a VM. And although we have 20 different file conversions, they're all running in the same VM. If one of them gets stuck because of the bug, all of them go down. If one of them is slow, if one of them hogs up memory, we need to increase memory on the whole VM. PDFs are stupidly memory hungry if you do GhostScript. So we were running this on high memory VMs, although generating an SVG doesn't really need that much memory. And this is where kind of we were going for the worst common denominator of the whole thing, because that's how the incentives work. Now, then Lambda came along, and Cloud Functions came along, and things like that. And we realized that instead of kind of running these VMs that are basically shells around small functions that we need to do, what we started building out is just a bunch of small APIs that run on Amazon that are completely separated, and where we can run the SVG with 64 megs of memory, we can run PDFs with this, and they started becoming a lot more independent, and they started becoming a lot smaller, they started becoming a lot easier to maintain, and we got to this point now where when we need to change something slightly more, we don't alter the code at all, we throw it away, and we pretty much write that module from scratch. We got into the point where modules are so interreplaceable and kind of so small that we can benefit from learning of writing something 6 months ago and rewriting that part from scratch where the rest of it kind of stays the same. And kind of Cloud Functions kind of pushed us in that direction. And they pushed us in the direction where we are incentivized to do better things. We're incentivized to create a better architecture. And that's because kind of the way Lambda is priced and the way Cloud Functions are priced pushes you to small, loosely coupled things. Lambda is mostly priced on the maximum amount of memory you want to use and the time you run in the processor. So if you have a PDF exporter and an SVG exporter, and the PDF exporter requires a gig of RAM, the SVG doesn't, you're incentivized financially to kind of run it as 2 separate modules, because then you pay a lot less for SVG exports than you would if it was together. And kind of this is where it really clicked how revolutionary this is, because it's pushing teams and pushing companies to create more loosely coupled modules, to create more modular software, which is kind of pretty much last 20 years. Everybody's been saying this is a good idea, this is a good idea, this is a good idea. But our architecture commercially was incentivizing people to do something else, where the deployment architecture is now really incentivizing people to kind of do something that is completely different. Now, Lambda, my experience is mostly with Lambda on Amazon, so I don't know how things are at kind of Google or Microsoft functions, but pretty much everybody copies everybody else. And just as a frame of reference, kind of the price for Lambda is something like the first million requests are free per month. And after that, you pay something like $2 per million requests. And they're also charging you for 100 milliseconds in the processor times the memory you want to use. And kind of this is something like $8 for 1 million times 100 milliseconds at 512 megabytes, which is kind of a reasonably good VM. Now, if you multiply all that and kind of add it up, a fully utilized VM at 512 megabytes costs something around $14 or $15 a month. Now, that's about 5 times more expensive than you can get a dedicated VM. But at the same time, it's kind of $20 more expensive. And at $20, kind of, it's really not worth even thinking about the other thing, because Lambda puts some things in for free that are really interesting. Plus, kind of, you know, if you don't utilize it, you don't pay for it, which is really amazing for kind of very cheap and stupid experiments. So one thing I started doing is I started doing these kind of incredibly cheap, stupid experiments all the time and throwing them out. For example, one of the things we built is this repository labels generator for GitHub, where kind of you type in the name of the repository and the owner, and if the internet works in this country, yes, it gives you an SVG that you can then include. So this is about 20 lines of code that is not particularly smart. And I can run this on my own website, I can run this on my own VMs, I can run this on anything I want, but then I pay if people don't use it or if people use it. This way I pay when somebody actually wants to generate something. Plus, I've put this in front of CloudFront, so kind of I don't pay even for that because I'm caching these things. Another stupid thing I've created with this is kind of this Wikimind that's a visual explorer for Wikidata. When I do my presentations, I often try and explore kind of connections between entities, words, languages to make stupid puns, and then kind of I've created this thing where you can put in pretty much anything, and it goes to Wikidata, collects some shit, craps it together, manages that, and kind of starts creating a mind map of the whole thing, and then goes and starts fetching other things that are related to that, and kind of keeps on doing that. And now I can explore, you know, random stuff when I'm doing presentations. Now, this requires me to connect to third-party API, to expose the web server, to kind of do stuff that is relatively common. All of it is boilerplate. Lambda allows me to do this in about 40 lines of code. And while I'm actually using it, I pay for that. While I'm not using it, it's just sitting there, and it's kind of perfectly fine. And you know, we started building a ton of stupid things, like we built a support, IT support bot for Slack, where you can say, well, why does Australia not have internet? And then it goes and, come on, it goes and kind of comes up with a random excuse. I don't know if you can see this. What does it say? So your message is very important to us. The problem was caused by the boss's kid. Yeah, OK. So then you can say, why is the net so slow? Then it goes and kind of fetches another thing. So, you know, elliptic curve seems to be fractal or whatever. So it doesn't matter. It kind of generates some. So for things like this, where you want to do a very small experiment, you want to see how it works, you want to kind of install stuff, Lambda is absolutely perfect. Because it changes the incentive, so we no longer, previously, you know, I was running my web server, I would probably put all these 3 things in the same place. Now, these are kind of running completely separately. They're all modularized. They're all running outside now. And as I said, the first million requests are free per month. So until you actually kind of ramp up some serious usage on any of these, you're good. Now, there's a couple of things that are really revolutionary about looking at these things like small functions, small APIs compared to VMs. Because apps like Heroku platform or kind of Azure apps or kind of Google App Engine and things like that, they were incredibly interesting because they started handling a lot of stuff I didn't want to handle, like routing, like task dispatch, like restarting, like monitoring and things like that. And Lambda kind of pretty much gives you all that for free. So it gives you execution on top where you don't need to worry about failover anymore. It's there. If this thing gets stuck, it's just going to start another one. If you start being bombarded by 1,000 requests, it's going to scale. If you are not using anything, it's kind of quiet. And it will scale automatically, upscale, downscale, and things like that because you're paying for the time in the processor. You're not paying for VMs. The other thing that's kind of really interesting about this is whenever we were running stuff with VMs, we had to worry about failover. You have to have at least 2 VMs for everything. If one goes down, you have to kind of get to another one. If they're busy, you have to kind of load balance. You have to. With this thing, it's just kind of magically there for you. And kind of the paying for actual usage is quite revolutionary. But the other thing that kind of Lambda gives you out of the box is kind of it comes with all the batteries included. It's like one of those toys in the shop where you can press and it immediately does something useful. So it does all the kinds of stuff like task dispatch, monitoring, control, restarting, and a ton of other things that now allow us to finally just focus on the problems we want to solve, rather than dealing with all this boilerplate stuff. Now, I used to joke that Lambda is so easy that it allows even children to create stuff in the cloud, and I got challenged on that. So today we're going to try and kind of probably break the Guinness record in the youngest person launching something useful on the cloud. And my son here is going to kind of try and create a Lambda and launch it for you. So let's see if I can get this up. Okay, so the way kind of Lambdas are created with JavaScript, at least you can do it in other languages similarly, is you need to define a handler that Lambda is going to call. You're no longer thinking about apps, you're no longer thinking about VMs, you're thinking about a discrete piece of code that needs to run. And generally kind of you define in Node.js at least, you define a handler for a function that is going to execute. And this function inside Lambda has 2 important arguments. So the first argument is going to be the event sent to Lambda. I'll talk about this later, but in case of a web request, this would be all your get, post, form parameters and stuff like that. In case of a message queue going out, this would be the message and things like that. So you get a trigger, you get an event. The second parameter is the context of the Lambda function. And the context of the Lambda function is kind of giving you access to how much time you have left and where the function is running, what the privileges are, who's the user calling the function and things like that. But it also has a couple of kind of useful methods you need to know. Succeed is one of them. And succeed basically terminates the Lambda. And you tell the Lambda, well, this is my result. So pretty much at this point, you can tell it to run whatever you want. And it will kind of return the result back. And the succeed method is important because kind of Lambda assumes that your function is going to be asynchronous. And you're going to be talking to some other stuff. And so at the end, you call succeed. With the latest version of Lambda, there's also kind of a notified callback and things like that. So at this point, this is pretty much all somebody needs to do to create a Lambda function. And now we're going to deploy to the cloud. So can you please save this? And one of the things that's really interesting with kind of Lambda is they've made the programming model incredibly simple. They've made the configuration model stupidly complex. Incredibly stupidly complex. So it takes about 120 lines of shell script to deploy that thing into the cloud. And Milan is not going to type 120 lines of shell script. We're going to use a tool that kind of does all this for us. So this is actually kind of a small tool that I'm contributing to. And it kind of automates all the boilerplate required to get the Node.js function running in the cloud. So what we're going to do is we're going to tell it to run in a particular region. And when it runs in a region, kind of Lambda support for Sydney went live, I think, last month. So we're going to try that now, not to have to use kind of the pipes going out of Australia. And in order to deploy a Lambda function to the cloud, what you do is kind of you provide a region. And we're going to say the region is, I think, AP Southeast 2 is Sydney. So, and kind of the other thing that you need to give this tool to deploy is the main function you want it to run. And then it's going to kind of zip up the Node.js thing, and it's going to package all the dependencies, it's going to validate that you have the right package, it's going to create all the privileges and everything. You have Southeast 2, not Southeast 2. Go back. Yep. Good. Southeast 2. So 2. Number 2. Good. Fantastic. So the other thing we need to give it is the name of the handler we're running. And let's expand this a bit. OK, and you need to give it a handler. So handler. So the handler is going to be kind of the main function we created. We saved it to app.js. So that's kind of app, and then we'll call the function handler. So that's going to be app.handler. And now when you punch enter, kind of Cloud is going to start zipping this thing up and deploying it and kind of pushing it to AWS. So what this does is kind of it provisions a kind of VM template. It sets things up, and because it's running with it's running with Node.js, it will package all the dependencies. Should you have dependencies and things like that, and now it's live, and it gives us, well, you know, you have your NDC Lambda function, and we can now test it. Can you try and test it now? Yes. So. We'll use a shortcut to execute this. Again, Amazon CLI is pretty good for this, and it only takes one command line to actually kind of test this. And we're going to execute this without an event, because it doesn't really use any particular events for this. And let's see what's going to happen. Yes, good. So we have a function running in the cloud now, and kind of it's so easy, even a child can create it. That's kind of pretty cool. So, OK, so so kind of what's really interesting about this now is what we can do with this thing. Because unlike normal functions where you have to call them with something, Lambda you can call pretty much on anything. Which means if you're running in Amazon, you can call it when a file gets saved to S3. So remember when I said we gave our users direct access to files? That means that when somebody creates a file, I don't need to do anything from the browser to actually call an API to convert it. Lambda can kick off automatically. Or when something happens in the event log, Amazon has these CloudWatch events where you can say, well, if this thing happens for more than 5 times during the last 10 minutes, and the aggregate value of this is this, and this is this, relatively complex business rules, you can kick off a Lambda. Or you can kick off a Lambda where there's a message on a message queue. Or you can kick off a Lambda where there's a workflow through Amazon workflows. Or you can kick off a Lambda where there's a record coming into the database, or you can kick off a Lambda on anything. I remember 15 years ago, I was a relatively decent Oracle PL SQL programmer. And I was always so amazed how in Oracle with triggers you can do pretty much anything. And it was all magical. And we got triggers now on the cloud for databases that don't support triggers, because you can set up Lambda. Plus, you can do scheduled tasks. So there's cron in the cloud that you can make run stuff. And we started, stuff that I'd normally do with the cron on my machine to kick things off. I no longer need to do that. It's there. One of the most interesting things that it also does is this API gateway. API gateway allows browsers from the web to kick off a Lambda. And that starts to become really, really interesting from the perspective of building out apps and doing these small APIs. Because if we are incentivized to keep them small and modular and independent, and we can set up the browser to call these things when it needs to call these things, pretty much we can run a Lambda for a button. And that button function can be pretty much independent of all the other button functions and things like that. So the fact that Lambda can be called by so many different things is absolutely amazing for me, as that means that you don't have to have the code that listens to these queues. While migrating from Heroku, for MindMap 2, we started migrating the entire backend from Heroku to Lambda. We deleted about 50% of the code. There's about 50% of the code was, I'm going to connect to the SQS, I'm going to wait on this, I'm going to restart the connection if it breaks, I'm going to do a lifecycle check, I'm going to validate and download the entire file, I'm going to do this, I'm going to do that. All that is gone. Because Lambda gets called when the file is in S3. That's done. Or when the message is on the queue. Magically gets done. So that's another really interesting effect of this, is that we started deleting a ton of this code. And the less code I can maintain, the better, because I'm not really good at code maintenance. So that's another really interesting incentive for me. So configuring Lambda is reasonably complicated, but when you throw API gateway into the mix, that becomes really, really stupid, because you start having to define JSON templates, conversion templates, XML templates, sending things back and forth. And the whole environment on Amazon is geared towards executing Java code. So it took me a while to actually figure out that the main templating thing they use looks like Velocity, and it actually is Velocity. And you have full access to all the Java APIs underneath that, but it breaks stuff for JavaScript in some many really interesting ways. So what we started doing with this is we try to simplify the whole deployment, and I mentioned this tool that does stuff the way JavaScript developers expect out of the box. So we looked at how can we make this so simple that people feel right at home. And I think we've made something that looks like you're creating a lightweight web server in JavaScript, and it's actually configuring the whole magic underneath. So we're going to try our luck once more and do live coding on the stage. And I'm going to get Milan to create a web API now. Come on. Good. So we're going to recreate this as a web API, and you're going to see how easy it is to call stuff. So at this point, when you can call things from the web, so clients can call it directly, and there's some infrastructure around this to provide authentication and authorization and things like that. Plus, we can now expose other APIs very easily to the whole thing. And we can remove all the infrastructure code around waiting for tasks, dispatching, organizing workflows, and things like that. We're left with the meat of the application that's really just the business code that we need to run. And I think that's another really interesting set of incentives that this thing opens up. So when you have this architectural push to create small, independent, modular things that don't really interact with each other, plus kind of you remove most of the infrastructure code because Amazon can honestly do it better than you can. And this is kind of really, really amazing, and that's why I think it's kind of a revolution. It's something that pushes people to have a completely different set of incentives, and it's something that pushes us to create a completely different architecture. And the thing that we need to include into this is kind of the wiring module. So the deployment tool I showed you earlier, Milan showed you earlier, doesn't really influence your code in any way. You can kind of deploy any JavaScript function, but if you want to use the kind of web wiring thing, then there's this dependency that's relatively minimal and has no other dependencies. So it's only about 50 lines of code, and it only does wiring. And you use it by instantiating a new API there and pretty much doing stuff as you would in Express. And it's kind of taking care of all the other things for you. So it will package up all the get, post, and kind of form requests. It will do all the dynamic parameters and everything and just expose it for you so you can handle it easily. And once we started kind of moving from all the weird shell scripts that are used to something as simple as this, that really allowed us to migrate the backend very, very quickly. Because we were taking stuff, all the kind of payments processing, all the file conversions, pretty much everything that we had people doing in all these kind of Ruby VMs and Node.js VMs on Heroku, we've now decoupled into lots and lots of small functions that are kind of serving their own purpose. And one of the most important things, at least for me, when we were doing this migration was to kind of mentally start decoupling things again. Because kind of I think, we get taught to kind of, everything needs to be a small object, everything needs to be a small function, everything needs to be a small module, and then you think about, well, I'm going to package this up in an application that has 500 handlers and has this session that kind of becomes magical 6 months later, has these cookies that nobody understands 3 months later, and it's all kind of bundled together, where now we can start kind of doing things much, much easier. What's really interesting, again, about the whole thing is if you have a particular request that takes a long time, or a particular thing that needs more memory, or a particular thing that kind of requires access to some third-party things, but you're really scared about exposing the API because of security, you don't want to open up everything, you can kind of modularize and lock that thing down. Everything else can go somewhere else. And kind of the API set is very similar to Express, so you just do .get and or .post, .put, do you want? Deny. Good. So the API kind of, you provide a path and then you give it a handler. And the handler is any kind of JavaScript function. And the function will automatically get the request object with all the post parameters, get parameters, the body, and pretty much everything. Lambda and API gateway for kind of the JavaScript version are geared towards executing application JSON. So by default, you'll get the JSON object in from the body. You'll get kind of post requests and stuff like that, and you're expected to return a JSON object back. If you don't want to use JSON, it's kind of trivial easy to switch it to plain text, HTML, stuff like that. For example, for the repo labels thing I showed you, I actually serve an SVG image. I compose an SVG image in a Lambda and kind of serve it back. So in this case, kind of from the handler, you just return the results out. If you want to do something asynchronous, you push out a promise. And it will wait for the promise to resolve. And now the AWS SDK also supports promises since a couple of months ago. So it's kind of really trivial, just kind of go into DynamoDB, return the result of DynamoDB, and that's it. And this allows you to do kind of filtering, authentication, and transformations and stuff like that. So now when you save this stuff, we can now create a web API. You need, no, you need a colon. So let's try and deploy this to the cloud. And in a case of deploying a web API, because it has these roots and stuff like that, instead of defining a single function to be deployed, we provide a whole module. Again, just a region and a module, and that's it. And if there were any package dependencies in npm package JSON and things like that, everything would go to the cloud. And Lambda has this thing where it limits you to about 1.5 gigs in total for all your versions. Because every time you deploy, it just creates a new version. And I'll talk about that. I think that's also kind of quite revolutionary because it pushes people to another really good pattern, but we'll talk about that later. So if you try and bundle too many dependencies into the same thing, then you get fewer deployments you can do, which is, again, incentivizing people to do small modular things. Don't bundle the whole internet with your app. And that means there's less risk for kind of an area of coverage that can go wrong. And we need to define the API module as well. So one really interesting thing about this whole idea of versions is pretty much every time you do a deployment, it creates a new numeric version of your app. And you can do labels on those versions. So you can say production is version 46, development is version 29, testing is version something, and it's trivial easy to provision these things now. I remember kind of, even with cloud VMs and stuff like that, we'd do testing on our machines because it takes a long time to provision the whole thing. Well, now it's kind of 20 seconds to provision something, because now this is configuring a web API. It's going to take slightly longer because it needs to do lots of weird things, as I mentioned. But it's relatively easy to set up a new version. So what we tend to do is pretty much every developer has their own version that they're playing with on the cloud. And when we're happy with that, we just promote kind of the version we like to production. Rollback is trivially simple. Just reassign an alias. And all your versions are there for kind of posterity. And what's really interesting about the whole thing then is it pushes people to do multi-versioning correctly. Because then it makes you think about, well, we don't have to upgrade the whole set of our users immediately. We can give something to people who really just need this feature, and it's half-baked, but these people need it. Let's connect them to this version. Everybody else connects to this old version. And kind of stuff like that is really amazing. So when this thing runs, it prints out the URL. And you'll see that kind of the start of the URL is this weird thing. That's the ID of the API. And now I can kind of chuck this in the browser. And we have a result. So we have a function running on the cloud. Now, this function, although kind of it's relatively minimal and done by a child, has bulletproof load balancing, bulletproof scaling, bulletproof monitoring, bulletproof dispatching. Pretty much, you're benefiting from all the knowledge that somebody who's created a massive data center like Amazon or Google or Microsoft has put in over the last, 20 years. These people have patents on cooling servers. That's how far they go. Now, he can benefit from all of that just by doing this stuff. Now, as I mentioned, you can do lots of weird things with this, and it's really perfect for small experiments. But where this thing starts becoming is really this kind of combination of the business and technical impact. That's why I think it's revolutionary. So the technical impact is you get pushed to these smaller functions, you get pushed to smaller modules. Everything is pushing you to create more independent things. The whole microservice phenomenon is really, this is pushing us to create something like that. It's making multi-versioning trivially simple. And it's forcing people to kind of think about multi-versioning and benefiting from that. Multi-versioning is stupidly difficult to do if you try and do it manually. Here you get it for free. And the risk is going down significantly because kind of you can roll up, roll down. It's there. You can kind of just rewire these things. The other thing that it's kind of really providing is ops by magic. There's a ton of buzzwords that already started in this space. And one of the buzzwords that kind of people mention now, there's 2 talks at this conference about that. It's serverless. And kind of this whole serverless thing, then people say, well, it's not without servers. It's kind of, you don't have to worry about servers. And somebody says, well, I didn't have to worry about servers when I had VMs. And I say, well, but kind of the whole idea of this is not to think about applications anymore. Think about APIs. And these APIs are running somewhere. For MindMap 2, for example, kind of, we hit this kind of serverless point about 6 months ago, where browsers are directly uploading files to S3, Lambdas are kicking off to convert them, browsers are checking on S3 whether the conversion is done, all the payments and everything like that. They're very small functions that the browsers connect to directly, and there's no central app anymore. The central app is a static HTML file running on CloudFront. It scales much better than Heroku will. The other thing that kind of is again a buzzword that people mention about this is kind of this zero ops thing, or no ops, as opposed to kind of DevOps or whatever. And I think kind of ops is still interesting, but from a different perspective. Ops in terms of maintaining your queues, maintaining your database and stuff like that, gone. Ops in terms of thinking about what you want to package, how you want to package it, how you want to test it, how you want to set up your deployment pipeline becomes really interesting. By the way, I've kind of researching this thing yesterday, I've learned that you can also trigger a Lambda from the Amazon code deploy pipeline. It's kind of their continuous deployment pipeline. So you can set up a Lambda that kind of packages other Lambdas. It's kind of a meta Lambda, I guess, or something like that. And one thing that's kind of really interesting from a business perspective is that it kind of pushes you to think about paying per usage. So small experiments are really cheap, but when they need to scale up, this kind of ops by magic is going to provide the scaling. So one thing that kind of is particularly problematic with this whole thing, at least for me, because I'm a fan of automated testing, is that kind of it starts becoming challenging to actually prove anything locally. Because there's so much magic running in the cloud, you can de-risk that your functions work locally, but connectivity, configuration, wiring, and things like that becomes an interesting problem that needs to be solved. Things that I didn't really think about when kind of doing stuff on dedicated servers or VMs now become really interesting. And one of them is kind of testability. So we have a bunch of kind of these tests now that run functions locally. I mean, the code that Milan wrote is just a JavaScript function. It doesn't connect to anything in particular, but we also run some really interesting integration servers in the cloud now, automated. And kind of generally, I think testability is going to be a really interesting problem going forward. Now, another really interesting aspect of kind of this being functions and not being apps is that there's a couple of limitations to Lambda that are kind of forcing us, at least, not to be able to do everything we want. The first thing is that the total time a Lambda is limited to is about 5 minutes. You can make it lower. By default, it's about 3 seconds, which I think is reasonable. If your API doesn't respond to a web user in 3 seconds, people are going to think it's not doing anything. But file conversions, background runs, and stuff like that might take a longer time. So Lambda has this hard limit of 5 minutes, after which it's killing your VM. And you need to kind of think about packaging tasks in smaller things. It's not necessarily that bad, but what that does is prevents any kind of streaming clients from this. So, which is kind of is good and bad at the same time. So instead of just streaming stuff from Lambda, it makes you think about, well, maybe we should put this on a file storage somewhere and let people stream it from there, or kind of have another API, or have some kind of push it to a message queue where people are kind of consuming it from a message queue. So again, from one perspective, it's kind of pushing people to good architectural patterns. From another perspective, I showed you kind of the support bot for Slack. I wanted to build the same thing for Twitter. And for Twitter, there's no webhook API. For Twitter, you have to set up a service that connects to Twitter and listens to their feed, streams it in. That's pretty much impossible to do with Lambda now. And things like that, I kind of still left with running a separate VM, connecting to this. But that's something that is interesting to see how it's going to be solved in the future. The other thing that kind of this whole ops by magic and scaling by magic and things like that forces people to do is pretty much a share nothing architecture, where Lambdas, at any given point, 100 of your Lambdas might be running concurrently or one. There's no stickiness, there's no sessions, there's no, thinking about stickiness and sessions gets people to think about VMs. These are not, physically they are VMs, but you have no access to that. And that's why there are no sessions, no streams, it's a share nothing thing, which again pushes people to share stuff through databases, share stuff through queues, share stuff through S3 or some kind of other cloud storage. And lots of people complain about Lambda that, if you have a fully utilized VM, just renting a VM from Amazon is 5 times cheaper, which is true. But that's if you think about this thing as a VM. What if that VM starts getting clogged? What if you start getting too many requests? What if that VM is not doing anything? And that's where thinking about these things as VMs is no longer useful. And which is why I've mentioned over and over, I think this is truly revolutionary. So to finish this thing off, is that configuration is a really big problem, and it will take more than 40 minutes to just go through all the screens you need to do to configure this thing. Luckily, Amazon has a good command line interface, and other cloud providers do as well. And there's a nice article on Martin Fowler's website about serverless, which is not written by him, written by somebody else, but a really, really nice article where they talk about how, because of the whole octopus of connecting to everything, everywhere, and scaling, the configuration itself needs to be relatively generic, which means it needs to be hard. But if you narrow it down to a particular use case, like running Node.js, you don't really need that much complexity. And Werner Vogels, the CTO of Amazon, did a fantastic talk about 6 months ago where he talked about the top 10 lessons they've learned from 10 years of running AWS. And one of the lessons was that the market wants primitives from Amazon. The market doesn't want high-level tools, because then people come up with lots of interesting ways of combining those primitives. Now, what you've seen now is Milan demonstrating this tool called Cloudya.js, which is an example of that. It's an open source tool that combines those primitives, narrows down the use case, and sets things up the way JavaScript developers expect out of the box. So it will use NPM for packaging. It will use all the JavaScript concepts, where there's a ton of alternative tools for Java, Python, and other things. Cloudya does not try to abstract away AWS. I like to use AWS APIs directly. I like to connect to S3 and Dynamo directly, so I know what I'm doing. But there are some relatively interesting other projects like serverless. Serverless is, again, geared towards JavaScript, but it tries to abstract away the cloud. And it provides a ton of services around dispatching, service location. So it's a framework. It's not just a deployment tool. And I think last week they announced that you can also deploy serverless apps to Azure. So it's bridging the gap between AWS and other things. Apex is another interesting project for the JavaScript and Node.js space. Apex is a deployer like Cloudya is, but Apex does some things differently. It tries to be a bit more generic. So it allows you to deploy binaries as well and things like that. So with Apex, for example, you can deploy a Go language runtime and do a Lambda in Go, although it's not supported on Amazon officially. Or you can deploy a new Node.js runtime. So Lambda for a long time used to run on Node 0.10. With Apex, you can deploy Node 6 and run your Lambda in Node 6 and stuff like that. So for me, the choice between these three is, if you're happy using AWS directly and you want to do pretty much JavaScript setup out of the box without any configuration or anything like that, Cloudya is very simple. If you want to abstract away the cloud, if you want to do your own service locations through this new framework, then use serverless. And if you want to go for really esoteric stuff, do Apex. And that's pretty much it. I hope I've tickled your imagination at least a bit. We have 5 minutes left for questions. Does this make sense at all? Do you see why I'm so excited about functions rather than VMs? And I think this is kind of truly, does anybody have any questions you'd like to kind of ask while we have time? Yes.
And then so you just need to sort of listen to the events of anything.
Yep.
Server side, so basically
Yep.
you're abstracting that all away.
Yep. Yeah, so you get an event, you can control where the events are coming from, you can authenticate and stuff like that, but for the most part, you're completely right. You get an event and you do something about that. That's it.
I think your mention of stream
So there's lots of ways of notifying the client. So for example, what we do with file conversions is we send the client a signed URL on S3 where the file is going to be. So then the client kind of polls every 5 seconds until the file appears there magically. Again, this is kind of trying to push people into doing things not inside that function, but decoupling. Amazon also has a MQTT service that is this kind of IoT message queue for devices. So you can send messages to, like notifications to mobile devices. It also has a JavaScript client. So the browser can connect to the queue, you can push to the queue from Lambda, and that's it. It's kind of, I assume it's implemented through WebSockets, I don't really know. But at the same time, it doesn't really matter how it's implemented. You know, as far as Lambda is concerned, push a message onto the queue, the client gets it, and that's it. So that will be a way of doing it. So the functions are kind of trying to push people to use these highly scalable services that are provided there. So you decouple your stuff from that. Does that make sense?
You mentioned that testing might be challenging. Could you let us know at a high level how are you solving that challenge?
So the question was kind of testing is a bit challenging, and how are we solving that challenge? So I'll give you a short answer and a slightly longer answer. So the short answer is go to this website. And then there's a tutorials page, and then there's how to design testable Lambda functions. It's a very, very long article detailing how we're doing stuff. A quick answer is we're doing hexagonal architecture. I don't know if people are aware of hexagonal architecture. It's kind of a design pattern where you're not allowing your code to talk directly to external services. You're not allowing external services to directly talk to your code. You're putting a layer in between. So then you can kind of really nicely test the core part of your system by providing ports and adapters for kind of different things, including a test API. And then you need to do bulletproof integration tests around kind of the layer that's outside. So we have a mix of kind of tests that prove that the code is working correctly locally in the cloud and things like that, and then a lot of integration tests that kind of prove that things are connected correctly. So that's kind of a slightly longer answer. And again, that's nothing to do with Lambda in particular. It's just that because everything is so magical, it again pushes you to kind of use a good architectural pattern. So if you're used to domain-driven design has similar concepts as kind of the core domain and kind of interface domains and translation layers and kind of the anti-corruption layers in domain-driven design are kind of related to that. So it forces people to kind of separate out the communication part of the software from the kind of processing part of the software so you can test it independently. Good. We have another question over there. So pretty much, if I run the deployment again, or if there's a record of the deployment here, you'll see that it's kind of creating a role first. And every Lambda function has a security role it executes under. This thing is kind of by default creating an empty role that just allows you to run a Lambda. But you can provide policies and say, well, these people can call this thing, or I can call, this Lambda can call other things. So it's kind of, on Amazon, it's kind of pretty well done through roles. And then you can assign things to different roles, and you can control who can call the function, or how it can be called, or what that function is actually allowed to do to access other things. On Amazon, there's this federated authentication thing called Cognito. So you can allow only authenticated users to do this, or unauthenticated, or kind of, so it's all possible. It's just that kind of for a very simple use case where you want to do course, you want to allow the browser to connect to it, you want to do a background thing, this does it automatically for you out of the box. And then you can configure more complicated things. Yeah, you can make it as broad or as narrow as you want. And kind of the deployment tool will also, if you can provide security policies to it to deploy with the API. But by default, it creates, because that's kind of the standard use case is to allow the browsers to call your functions directly, and then you authenticate inside it. So that's kind of, that's why there was no configuration here. But I could have configured this to allow only me to call it, or only you, or anybody who's authenticated through Google, or even provide a custom authentication thing to tell who can do what. So it's kind of, you know, like I mentioned, Amazon can do ops way better than you and I can. So they've kind of thought about that, and their solution is already integrated into the whole thing. The reason why you didn't, that's one of those 20 steps you need to do to deploy this, but the tool does it for you, and it does the kind of simple case first, unless you configure it to do something else. So the question is, have I faced issues with spiders and bots on the API gateway? I've not. The API gateway, you can limit it so that only people with a particular API key can call it. And that's supported pretty much out of the box. So for anything that's more serious that we need to do, we'll put an API key, and then the browser is going to get the API key with the CDN deployment. Throttling and things like that are really, really well done. So you can tell your Lambda to start throttling at a certain point. You can tell your API gateway to start throttling at a certain point. The GitHub label generator that I showed you, it's actually done so that CloudFront is in between Amazon CDN. So the CloudFront is in between the browser and the API gateway. So bots and spiders can kind of take a hit at Amazon's CDN as much as they want. They're not really going to hit me. So the labels are generated on demand and regenerated only every kind of 15, 20 minutes. So that part is pretty well done. We're not, MindMap 2 has about 250 active users per month, and kind of the average session is about half an hour. So it does get kind of reasonably busy. It gets more busy than you can do with kind of 2 or 3 VMs, but it's not Google scale. So I don't know how, I don't have any experience kind of how Lambda would behave at Google scale. Having said that, most of these APIs tend to come from Amazon actually opening up the stuff that they're using themselves. So I think it's reasonable to expect that kind of it can deal with that case pretty well. Again, Amazon can do ops much better than you can. Managing secrets. So API gateway has this thing called a stage, and you can assign variables to a stage. So stage is like production, development, testing, my machines, your machines, and that's pretty good to keep keys in. If the API calls multiple Lambda functions, yes, then they'll get that, because the variables are in the stage there. Another thing that you can do that you don't, if you're not deploying through API gateway, is you can put in the key in the event itself. One thing is, so again, it changes. it takes slight adjustment to thinking about this. So, for example, we have, as I mentioned, the key use case for us is people upload the file to S3, Lambda kicks off, process it, saves to S3. Now, if you think about configuration there, for a normal VM, you'd have to configure where it reads, where it saves, access keys. With Lambda, you get an event, and the event says this thing is a file from this S3 bucket. So there's no configuration. That part you save back to the same bucket. There's no configuration. And you manage the roles to allow you to access internal resources. So there's no secrets. So the third option there is to use a file that gets deployed with the Lambda and then detect the context where the Lambda is running as dev production test, load the right JSON. The fourth option is to use something called the Amazon Key Service. That's kind of a hardware security thingy. We don't use that, so I don't have any kind of experience with that because my risk model doesn't really require that. But if you're really thinking about something that's horribly secret, I would keep it in the key service. Good. Well, thanks very much. I hope I've tickled your imagination at least a bit, and go and deploy Lambdas.